So you want to convert your car to electric? You've come to the right place. We do stuff like this all the time. Last time we were close on driving this Porsche, but for this episode, yep, we make it work. Welcome to the Electric Supercar channel. We love showing you how we're making this Porsche go electric. If you're not subscribed yet, make sure to hit that subscribe button for more episodes like this. We got the battery box in, installed the brakes and suspension, and put the axles in. If you remember from last time, we got the motor spinning after a lot of trial and error. This time we're gonna see if we can get it driving. For those of you who are new to the channel, this is a 1977 Porsche 911 Targa. So this one started as nothing but a shell, and we've been building it up. We've done the electrical, put in battery boxes and the motor. In order to get this one driving, we had to do a couple things. One of the main things was brakes, but we also had to get the battery box out one more time. We had to add one more plug. Customer wanted us to use a specific 2-in-1 DC to DC charger system, and it requires 2 plugs instead of 1. We're just checking everything, doing all the systems tests before we seal it back up. All right, so we checked the BMS, so we got all the thermistors enabled, all the cells are reading good. They're right around 3.7.
You know what? Joke's on you, because I know Morse code. Ha!
Negative. $19. And now we're putting it back in, just tightening everything up to make sure it's secure.
So originally on this Porsche, we had the gas tank, spare tire, and then the 12-volt battery up here. So obviously we've used this whole space, and so we need to figure out a new place for the battery. So the original thought is to make a battery tray right here and mount the battery here, because the high voltage battery is at this height. And so if we can keep that height going, we can give the customer a lot of trunk space in here on top of the batteries. So that's the plan. But this is the battery that we got. Traditional battery for the cars. I thought maybe we could go with like a smaller lithium battery. So we just got this lead time battery in. Oh, it's super light. This is their 100 amp hour Smart Extra Mini. It's got Bluetooth and BMS in it, and it's quite a bit smaller. It'll be a lot easier to package, especially since I can put it on its side or upright or on this side, whereas a lead acid battery you have to keep upright for the vents and everything. Just look how much smaller that is. I'm gonna see what these guys think about the weight.
Dude, that's super light actually. Ready? Yeah. Here, hold this, ready?
Oh, that is pretty light.
It's a 100 amp hour.
Yeah.
That's
So
awesome.
it's freaking beefy.
That's super cool.
And it's like a perfect charge voltage for our DC to DC converter.
Max continuous output power, yeah. So 12.8, yeah. Dude, that's a powerhouse.
Yeah,
That's
so
awesome.
I think we're gonna put it in the Porsche.
That's actually rad.
Sweet,
So
look at that.
cells.
It's got state of charge.
Shit, now
Got
I
it.
know.
Cells.
Temperature, capacity, current. That's cool. So it has a current sensor right on there.
We've got the battery mount in. Just had to countersink these so that the battery can sit flush against here. But we added some riv nuts on these 2, some riv nuts on these 4. Holds it really nicely. I mean, this is it. I think it turned out really good. Obviously, we 3D printed these first, got this order from Send Cut Send, got these little eyelets from McMaster, and then just these long bolts. So it's holding the battery in, and it comes back here. It's sitting on the tray. I mean, this is a super light battery anyway. But yeah, I think it turned out really good.
So we actually think this is pretty cool. It's the smallest and lightest 100 amp hour battery in its class. And it comes with smart Bluetooth 5.0. I really do think the coolest thing is you can check the battery status just with an app. So this features a high energy density and compact design. Has 20 smart protections for maximum safety. It is built for extreme conditions with low temperature cutoff, auto recovery from overload in 30 seconds. So these are EV grade cells planned for over 4,000 cycles. And one of the cool things is, opposed to lead acid batteries, it doesn't matter which way you orient it, upside down, sideways, any way is fine. And it's great for our vehicle, it can be great for your vehicle. They also offer lots of other things for camper vans, other battery voltages. So if you're interested in something like that, I'll leave a link in the video description below.
All right, included in our last send cut send order, we've got our VCU mount. So is what we're gonna use to adapt it to the body. I think it worked really well. We have just enough room, so I'm gonna make all the wires neat. So yeah, I like it.
So brakes for this one, we're gonna be a little bit challenging. So there is a spot for a master cylinder kind of under where the, I'll call it the steering rack is. There's really just not a lot of room there, and the customer did want power brakes. So this means that we would have to either create a unique linkage that would link the bottom master cylinder to a power brake system up top, or we could do hydraulic. So what hydraulic means is we're gonna have a master cylinder down below where the foot brake is pressed, have that go to a slave cylinder, and the slave cylinder is actually gonna be connected to the eye booster. So when you push on the brake, it'll push the master cylinder below, which will in turn push the slave cylinder up top, which in turn pushes the eye booster or the power braking system. That's how we're gonna go for power brakes. The other thing is we are trying to fit pedals and things that have never been used in this sort of car before, so we do have to come up with a unique pedal box. So essentially, after some quick designs, we're leaving this to John to do his fabrication magic.
Working on the brakes for the Porsche. Our solution for power brakes is this slave cylinder up here, activated by this master cylinder down below. That's connected directly to the pedal. This mounts like this, and will activate our eye booster here. So previously, we 3D printed these pieces and tested them out, and everything works out really well. But now we got our send cut send order, so we're gonna transfer the 3D printed pieces to aluminum. So first do that, and then we'll get it installed. Okay, that went really well. I'm getting ready to install some brake lines, the proportioning valve, front and rear brake lines, I think, and just some fittings. This is gonna go from here all the way, follow the same path down here, and then all the way to the back. Front here, waiting on one to go to the left side. That comes up to this bulkhead fitting. Pretty sleek setup, I like it a lot. These are part of the Willwood brake kit, and then these are what I'm adding to it. All right, so I'm getting ready to mount our master cylinder down here on the pedal. But first we need to get this plate installed. It's basically just to reinforce the thin metal around here. We really want to strengthen this. We're going to weld this in so that the master cylinder can bolt up. All right, so I ended up just cutting some threaded rod to make a stud. Got to make sure that this works. So here on the Porsche, we've been working on figuring out the pedal box assembly. I think we have a solution now. We're going to use this Willwood pedal box. Kind of took some dimensions off of the original one in order to make this combo setup. So this is a 3D print right now. It's holding the Willwood brake pedal, and then we've got this Porsche Taycan accelerator pedal. Just because it's floor mount, this bolts to this piece that will eventually have milled out of aluminum, bolts in where the original pedal box bolted into.
All right, we got some new things from JLC CNC. So these are the guys we use when we need things CNC'd. So lots of times we'll laser cut, but there are just those times where you need something CNC'd. Now let's see it. That is amazing how clean that is.
So sick.
So we anodized this one black. This is a pedal box basically for the Porsche, because we're doing a floor mounted pedal, and then we're also implementing kind of the brake pedal. This was a design we did, and you can see it's got lots of cuts and threads and things, but they were able to do it.
Oh my gosh, it looks exactly like the 3D print, which is incredible that they were actually able to subtract material in this way. That is so many fixtures, that's insane.
So this is the 3D printed version. We kind of made sure everything worked, fit the pedal. So yeah, and the anodized aluminum one looks like the exact same.
Incredible.
So next we have to get the brake pedal on. The way that the master cylinder or slave cylinder connects, it has to twist. So we're probably going to do that twisting before we put the clevis on. But yeah, we'll get it all fitted, show you what it looks like. So step one, it fits, which is great. All right, so there's the pedal bracket in position. So this one holds the, this pin pivot holds the Wilwood brake pedal. It goes through the firewall to a master cylinder. And then over here we've got the Taycan accelerator pedal. So it's held to the floor by the original mounts, the original bolts, and everything's nice and tight. This amazing part is from JLC CNC. So they are pros at CNC. They have an online tool that you can upload your part and get a pretty quick quote. Their prices are really good, and as you can see, the quality is outstanding. So if you need some CNC parts, I'll leave a link in the video description below. The pedal box has to be installed, and then the threads threaded into the pedal box, and then the nuts put on the outside. These guys a while ago, so Tony and Russ had wired up PDU, that's kind of controls everything, but when we did the Dynam Labs, we kind of just did that by itself. So now we've got them both integrated, and when we turn it on, it's live. We get brake switch, we get throttle, pedal. So the only other thing we've done is John's helped out with the brake system. So we are doing a hydraulic brake system. So I believe we're ready. I think this thing we can drive. All right, so if you're anything like us, we want to take this out as soon as possible. What that does mean though is we got to tape some things up or zip tie some things up out of the way. So we've got some coolant hoses and some things like that, some extra wires. Got to get those all up so we can just take this out. Doing some last adjustments here. Tony's putting on steering wheel. Steering is sometimes important when driving. So we don't have a gear selector for this one, so we're just doing some drive wires to make sure we can shift into gear. So go for it, Tony. Yeah, it's going.
Beautiful.
Say, where are the shift wires? Oh, right here.
So they're
Neutral,
labeled,
drive.
and we made them all red so you wouldn't get them confused. So you can touch it in the bolt holes.
Yeah. Yeah.
Or ground.
Is the car on?
No, you have to turn that to the right. Yep.
Click, 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 click. It's creeping. I'm just gonna go nice and slow. Go all the way left? Yeah. That's locked. Yeah, it's definitely like in a limp mode, or we got something not right. I mean, I can go to the floor with the accelerated pedal and it's not giving me full juice. So we can look at if it's got error messages, or maybe we just don't have a setting that it's like all the way full, which is fine. We kind of expect it. Are we okay to go park it? Yeah. Okay. No. So I'm gonna try and back in. Let me get my reverse wire. Okay, reverse. If you guys can kind of maybe just help make sure I don't hit anything.
Well, all the way to the lift?
You guys tell me?
Yeah, so
probably. All right, we are going back and forth with the Dynam Labs guys, making sure we've got the software dialed in for the Porsche. So they've got a new beta version out that we're going to be trying. We were getting some limp mode notifications, and so this should help solve those. Okay, we are flashing with new stuff to the inverter. This will hopefully solve our limp mode issues.
It'll be all green, and the last one will be red. It'll be like, failed. Send it down. Yeah, see? I f***ing knew it, dude. Yay, it went away. So go to main DI, see if it says drive ready again. No, it doesn't. It is not drive ready.
Okay.
No throttle, no shit. Salmon dry.
Nope.
How about now?
Nope. Now there's a warning or an error. VCU shift request timeout. All right, so with the motor controller and the motor, we're trying to find out, and I think we've understood that we've been trying to flash this as the wrong motor. So what we've learned from the company is that the motor is actually from a Model X. I know Model X and Model S kind of share motors, but we kept flashing it, telling it was a Model S, and that kind of gave it some issues. So we are now going to flash it as a Model X, and hopefully it'll behave. All right, so we're still learning about this motor. It was part of a dual motor system, and again, it still wants to think it's a dual motor system. So we need to still program it to be a single motor system. Yeah, it does not want to identify as a single performance motor. All right, so we are in the process of downloading a firmware tool for Tesla. That should be able to change the configuration on the motor that we need to change. We're doing some late night troubleshooting with the Porsche. It's been kicking our butts, and so I'm actually having some remote help. They're actually on my computer doing the help. I got my trusty sandwich I made at home, so kind of a midnight snack, but we'll get it done. So although we were able to get this to drive, we were in a limp mode. That means we couldn't just go full accelerator and do burnouts and things like that. Essentially, we're encountering a lot of different, I'll call it small issues, but issues nonetheless that are causing the limp mode. One is the customer purchased this motor and it happens to be a Model X instead of a Model S. We didn't really think this was a big deal because the program and stuff says, hey, Model X/S. And essentially it is the same motor. Essentially the programming inside the motor kind of tells it what motor it is. And for whatever reason, we can't get it to recognize that it's a Model S motor and a single motor. It still thinks it's a Model X motor and part of a dual motor system. So there's a couple key programming things that we have to sift through. So we are using the Dynam controller for this one. We actually do like it quite a bit. It works out well for this build because they allow you to use any accelerator pedal. And for this one, if you remember, we needed a floor-mounted accelerator pedal, where the other systems you had to have a Tesla pedal, and that just really wouldn't work well for this system. There's just no room or no mounting to mount kind of a firewall pedal for this one. It just doesn't work. All right, I was hoping we could come to a conclusion with the troubleshooting we're doing on the controller, but that's not solved yet because we're super excited that the Porsche is now driving, which is a very big milestone. So thank you for tuning in. See you next time.